In Lesson 4, the final lesson of Section 2, we will subtract proper fractions with unlike denominators symbolically. Now the process will involve using only numbers and symbols to find the difference. Our algorithm, our recipe, well, when subtracting fractions with unlike denominators, first of all, we find the least common denominator for all fractions involved. And in all of these examples, we will be using the least common denominator. We could just use a common denominator, but if we recall from a previous video, we realized that, of course, the numbers can become much larger, so we're going to stick with the least common denominator here. Once we have that, we write equivalent fractions where necessary so that all fractions have a common denominator. We keep the same denominator in our answer, subtract the numerators, and last but not least, simplify your answer if necessary. Let's consider a few examples. Subtract the following. In A, we have a half, subtract 1/8. Denominators are different. Got a 2 and we got an 8, so we got to figure out the LCD. The LCD for 2 and 8 is 8. So I need to rewrite that first fraction, the minuend, with a denominator of 8. Well, what's the equivalent fraction for a half so that it has a denominator of 8? Well, that would be 4/8. The subtrahend, the second fraction here, I'll just copy it down as is. Already has a denominator of 8. Next step, copy down that common denominator, subtract the numerators, check for lowest terms, and we are good. In B, 13 over 18, subtract 2 over 9. Denominators, different. LCD, though, will be an 18. Least common denominator for 9 and 18 is 18. So the first fraction, I just copy down as is. 2/9, I need the equivalent fraction. Well, if I double up 9, that gives me 18. So I double up 2, that gives me 4. Keep that denominator the same. Subtract the numerators. 13 subtract 4 is 9. So I get 9/18. Not quite done, though, because 9 over 18 can reduce. That will give us 1/2. And if you wanted to show a bit of workings for that, the GCF for 9 and 18 is 9. 9 divided by 9 is a 1. 18 divided by 9 is 2. In C, 6/7 subtract 3/4. Now, what would be the least common denominator for 7 and 4? If you were to list out your multiples and look for the least common, it would be 28. So in this case, I need to rewrite both fractions with a denominator of 28. 7 times 4 gives me 28. 6 times 4 gives me 24. 4 times 7 gives me 28. 3 times 7 gives me 21. Copy down that common denominator. Subtract the numerators. Well, 24 take away 21 will give us 3. Can it reduce? Not a chance. 3 over 28, final answer. And in D, 3 fractions involved here. We need to first of all figure out the LCD for 12, 3, and 8. And if you get the LCD for those 3 numbers, you will get 24. So we need to write 3 equivalent fractions here. All right. So 11 over 12. Well, if I double up 12, that gives me 24. Double up 11, that's 22. 3 times 8 gives me 24. So 1 times 8, 8. 8 times 3 is 24. 3 times 3, 9. Copy down that common denominator, which is 24. Subtract the numerators. So we're going to go 22 subtract 8 first. And 22 subtract 8 gives us 14. And then we have 14 subtract 9, and 14 subtract 9 will give us 5. So 22, subtract 8, subtract another 9, we end up with 5 24ths. Can it reduce? No way. So 5 over 24, final answer. So we'll clue up this lesson with a little word problem. On May 3rd, Ronaldo replanted a small pine tree in his backyard that was 5/8 of a meter tall. He measured the tree again on September the 6th, just before he went back to school, and discovered its height to be 9/10 of a meter. Our question? What fraction of a meter did the tree grow from May 3rd to September 6th? Well, on September 6th, it was 9/10 of a meter, and on May the 3rd, it was 5/8 of a meter. To figure out how much it grew, we need to find the difference between the taller height and the shorter height. I look at our denominators. Well, they're different. So I need to find a common denominator. My multiples of 10. Okay, let's do some multiples of 8. 8, 2 8s, 3 8s, 4 8s. Nothing in common yet. 5 8s. There it is. 40. So I need to write two equivalent fractions here to be able to subtract. 10 times 4 gives me 40. 9 times 4, 36. 8 times 5 gives me 40. 5 times 5 is a 25. If we subtract now, keep that common denominator the same, and 36 subtract 25 gives us 11. So the only question left now is, can 11 over 40 reduce? No, it cannot. So how much did the tree grow? The tree grew 11/40ths of a meter between May 3rd and September the 6th. And now I would like you to proceed to the activities for Lesson 4.